This is Algebra 2, Lesson 13-2, Rational Exponents. Let's start off with some vocab. So whenever we have this square root symbol here, it's not really called a square root symbol. It's actually called a radical symbol. So let's go ahead and mark this up and say that this is called a radical symbol. So whenever you see that symbol, you don't really say the square root of anything now because we might have a different index here. Maybe the index, and by the way, we should probably define this thing. This index could be some other number. By default, if you don't see a number here, you do assume that the default is 2. But if you see a different number there, it could be a cube root, for example. So you have to be careful now. We never really talk about the inside. We don't talk about Bruno. But if you do need to talk about the inside, then this inside you can call the radicand. Radicand. So we will be switching up the index here and doing some interesting things this lesson. So I'll talk about this why things work in a second. I want to talk about the new rule. So this is kind of the big new thing that we're doing in this lesson. It's all in this one spot. So here is the rule. If I have x, I have any base, and I take it to a fractional exponent, so it's like 1 divided by n, I have a fraction up here, then this is the same thing as writing the nth root of x. And that's it. It's a cute little short and simple rule. I don't know about the word simple, but it is a rule that you can follow pretty easily. So watch this. If I switch this n into a 3, then this n switches to a 3, and now I have this third root of x. So this is pronounced the cube root of x. So I would pronounce this the cube root of x. Just as if I had no number here, I would pronounce this, pretend that wasn't here, I would pronounce this the square root of x. This is not a square root symbol, it's a radical symbol, just to clarify that. So what about if I have a number in the top? What would I do then? Well, you actually have two different paths, and this is where it gets a little bit tricky. You get to choose whichever path you think is the best. So we have, I'm going to call this one path A, and we have path B. Because the way that powers work, you have to use your properties of exponents, and you can say one of two things. You can say this is either x to the power of 2 to the power of 1/3, or you can say that this is x to the power of 1/3 to the power of 2. And before I move too much further, like, let's ask why. Why am I doing these things? You usually want to do one thing at a time. This is doing two numbers at the same time. I usually want a 1 somewhere in the top or the bottom. There's a 1 there, and there's the 1 there. I want a 1 somewhere. This is a power to a power. This power is to another power, and this power is also to another power. You might remember that if I have a power to a power, like x to the power of a to the power of b, this is equal to x to the power of a times b. You multiply the powers when there's powers to a power. So I multiply these powers. 2 over 1 times 1/3 is 2 over 3, 2 over 3. And same thing over here. If I multiply 2 by 1/3, this is really 2 over 1 times 1 over 3. And 2 times 1 is 2, and 3 times 1 is 3. You get 2/3. So there's two different ways of writing this. And therefore, there are two different ways of writing the radical forms. So I can say that this is the same thing as, well, whenever I have a 1/3, I just saw it right here. That means you do the cube root of whatever's on the inside. The inside is x squared. So you can say this is the cube root of that x squared. And that is 100% mathematically correct. However, you can choose path B. And you can say, well, okay, if I have a power of 2, that means you square everything on the inside. And this inside, oh, that's x to the power of 1/3, which we just did right here. It's this cube root of x, then squared. So this is really the cube root of x, then quantity squared. I guess I don't really need the parentheses there. I can get rid of them. These are the same thing. That and that are the same thing. It doesn't matter if I put the 2 on the inside or the outside. Both are fine. In fact, you want to be strategic about what you do. And as a general advice, you can write this down if you want. When you're trying to solve powers, you want to try to do this method, path B, first, because you usually want to make things smaller before you make them bigger. If you make them bigger first, then it gets out of control and it's really hard to calculate in your head. So try to make it smaller first just to make your life easy. So now it's that time where I like to ask why. Why does this rule even work? And that's what I want to address right here. This is definitely not any formal proof. I'm just going to give some intuition behind why I can put this n over here and make it the same index So normally when we have this equation, we're trying to solve for x. You're saying, okay, I need to undo this power of 2. How do I undo that? And most students always say, you take the square root. And you just say, okay, you square root the left side, you square root the right side. If you're a really good student, you'd be like, oh, technically it's plus or minus on the right side. But we're going to ignore that just for a second so I can make this as simple as possible. And you say, yes, you're correct. The square root cancels out the square. Why that happens is not super clear, but it does cancel out, and you get x is equal to 2. I mean, technically plus or minus 2, but we're going to ignore that just for a sec. Perfect. So that's how we used to do it. Well, watch this. I can do it the same way with fractional exponents, because I can say this left side, I'm going to take it to a power of 1/2. If I do that to the left side, I also have to do it to the right side. And this is also to the power of 1/2 on the right side. And check this out. I talked about this before. When I have a power to a power, we multiply those powers. And 2 times 1/2, well, half of 2 is 1. And x to the power of 1 is just x. And this is just x. So the x is equal to 4 to the power of 1/2. And this is unfortunately one of those things where you have to use the fact that you have a radical. And this is really the square root of 4. But taking the power of 1/2 is the same thing as doing a square root. So I can go ahead and here and complete this. And this is equal to 2. It's the same thing. And then you have to add some extra rules that if this bottom number is an even number, then you have to have a plus or minus, and you can get back to that old rule where we had a plus or minus for our full answer. But for now, that's going to be my explanation. If you want a more thorough explanation, you can either look it up online or ask me after class. All right, so it's time to talk about what it means to be simplified in my class, because technically, if you don't see anything, you assume that there's an index of 2. If you don't see any number up here, you assume it's 1. But this is not simplified. If you ever have a 2 here, it's not simplified. If you ever have a 1 to a power, it's not simplified. This is really the square root of just x, because a 1 here, you don't write powers of 1. And if you have a 2 here, you don't write an index of 2. This is the same thing as this, but this one is simplified. So make sure that you're never writing a 1 if it's in a power. Make sure you're never writing a 2 if it's an index. I mean, I could make this even crazier and be like, well, technically it's divided by 1 also, because you don't write things that are divided by 1. You can make it much more simplified. All right, so some of these old rules will definitely help in this homework that we're coming up here. So if you have some sort of negative power, that means that you're going to flip it and make the power positive. So what do I mean by flip it? What is it? My indirect object pronoun? Well, it is this inside here, which is technically x over 1. I'm going to flip this so it's now 1 over x, and this now becomes 1 over x. And now this base x that is down here, it is no longer a negative exponent, it is a positive exponent. And similarly, if I have a negative power, it just means flip it. And what do I mean by it? It is this fraction 1 over x. It is now x over 1, and this turns into x over 1, which I'm going to erase because x over 1 is the same thing as just x. And instead of being a negative n, now that it has flipped, it is now a positive n. So my simple way of explaining whenever I have a negative exponent, it just means flip. Be careful here. If you have a negative out in front of your base, that does not mean flip. The only thing that means a flip is if you have a power of a negative. A power of a negative means a flip. All right, another thing that will definitely help on this lesson is knowing your higher powers. So what is 1 to the power of 3? Nice and easy. 1 times 1 times 1 is just 1. If you don't know your perfect cubes, you should definitely have it memorized. I have it posted in my classroom up above my 3D printer. Your perfect cubes are 2 cubed is 8, 3 cubed is 27, 4 cubed is a very confusing 64. I'm going to highlight that one because 64 is also a perfect square. Check this out. If you did not know, 8 times 8 is 64, and 4 times 4 times 4 is equal to 64. You have to be careful about the number 64. There's different ways of writing it. 5 cubed is 125, and finally 6 cubed is 216. You should know your perfect cubes all the way through 1,000, but for now, I'm just going to leave it at 6 cubed. I believe that's the highest that I'll ever assess on any quiz, test, or on a homework assignment. There also are even higher powers. Notice that I'm going up to a power of 4, 5, and I don't think I go to a power of 6. But if I do, I will come here and revise my notes and write 3 to the power of 6 and 2 to the power of 6. You should know that 2 to the power of 4 is one more multiple of 2 to the power of 3. So 8 times 2 is 16. And if I do another power of 2, that goes up to 32. I happen to have 2 to the power of 3 memorized, and I kind of go from there. I really should have 2 to the power of 5 memorized, but I only have that one memorized, and I keep going and jumping from there. With 3 to the power of 4, I just have that one memorized because it's much easier to write this one as 3 to the power of 2 to the power of 2, because watch this. 2 times 2 is 4, so a power to a power is multiplied. Everything there is okay, and guess what 3 squared is? 3 squared is 9, so 9 squared is equal to 81. You should have this memorized. 3 to the power of 4 is 81. And if you multiply that by 3 again, you get 243, which I think does show up once on the homework and maybe on a quiz or test as well. You should have that memorized. All right, well, that's enough for the notes. Let's go ahead and try some practice problems, which I guess are still technically part of the notes. So if you have something that says write it in radical form, it will give you something that's in exponential form. Exponential form meaning this is an exponent. It's a fractional exponent. It's a rational exponent, but that's okay. So you get to decide, do you want to write it one of 2 ways? Again, there are 2 paths because I have 2 different numbers in the top and the bottom other than 1. I can either do path A, or I could do path B. These are totally arbitrary paths. I didn't say like A means you always do the big one first and B means you do the small one. It doesn't matter. Here, let me just make it random and I'll say, okay, this one you're going to do the 1/7 first. So this is going to be x to the power of 1/7, and then all of that is going to be, again, to the power of 5. Why did I do that? You separate it so that there's 2 separate numbers, 1 for the 7, 1 for the 5. I chose to do the 7th first and then the 5 second. Again, this still works because a power to a power multiplies 1/7 times 5 is 5/7. That's one possible answer. I could also say that this is x to the power of 5, then to the power of 1/7, because again, when I multiply things, it doesn't matter if I multiply 2 times 3 or 3 times 2, I will get the same answer regardless. So from here, you can say, okay, when I have a power of 1/7, writing it in radical form where I have a radical symbol means I have a 7th root of x, and then it says after I do that, then take it to the power of 5. So after I do that, take it to the power of 5, and I have one of my 2 potential answers. Over here, it says, okay, do x to the power of 5 first. I'm going to write my x to the power of 5 first, and then do the power of 1/7, which means do the 7th root, an index of 7. So a radical with an index of 7, and I have another potential answer. I'm not sure which of these comes up more often in the back of the answers for the homework. I haven't looked that thoroughly at them, but both of these are valid answers. So if you wrote this, but the back of the answers is saying that, they're the same thing. That 5 can go inside or outside. It does not matter. All right, what about another one? What if I'm going backwards? What if I have a radical, there it is, and I'm trying to get to exponential form? What would I do? Well, there's no power here. It's super confusing. What do you do if you don't have a power? You assume the power is 1. So if it is 1, then you're going to go backwards and you're going to say that this number always goes in the bottom. So maybe that's one of the things you want to add down here, things to remember, that the thing that this index always goes in the bottom. A great thing to add to your notes, Mr. Sindel. So this is going to be x to the power of 1/4, because this number always goes on the bottom. This number always goes on the top every single time. And if that 1 was out here, I could have written that there. It's still on the top. This number always goes on the bottom. This index always goes on the bottom of my fraction. All right, so these are the much harder and much more useful problems that you'll be seeing for the rest of your mathematical careers, however long that lasts. So let's try this first one, nice and easy. Whenever I have a fractional power, I'm going to convert it to a radical form. I'm going to say that this is the same thing as 64 with a radical symbol, and there's a 1 here, which I don't need to write, and a 2 here, which I, again, don't need to write. When you have an index of 2, you just don't write it. And this is the same thing as this. Okay, so this is the square root of 64, and I happen to know that the square root of 64 is just 8, and I'm done. All right, let's try a slightly spicier problem. For number 27, or for this base of 27, I have 2 choices, right? Let me try both of them. I'm going to try the bad one first. I'm going to call it option A, and I have another option, which I will do correctly, which is option B. Here is a bad way of doing this problem. I could say that this is 27 to the power of 4 first, and then once I'm done doing that, I do it to the power of 1/3. Or I could have done 27 to the power of 1/3 first, and then to the power of 4. Here's why this first path is harder. It's not necessarily bad, I guess. It's just a lot harder. I have no idea what 27 to the power of 2, well, I have some idea what 27 to the power of 2 is. I don't know what 27 to the power of 3 is, and I definitely don't know what 27 to the power of 4 is. That's a gigantic number. It's too big. Here, let me write that in the notes. This number right here, that number right here is way too big. I don't want to work on this problem. This is going to make it smaller first, and that's why I told you before. In general, make your problem smaller first. 27 to the power of 1/3 is the same thing as writing the cube root of 27, and then once I'm done doing that, then I do it to the power of 4. Then I do it to the power of 4 like this. So this is much easier. I happen to know that 27 is a perfect cube because on my list over here, 27 is the same thing as 3 cubed, which means the cube root of 27 is 3. If you want to go really, really slow and show all of your work, you could do it this way. You could say that this is the cube root of 3 cubed, and then to the power of 4. I don't do that work, though. I'll be honest. I jump straight to here. I say, okay, cube root 27 is 3, and I still have to do the power of 4, and 3 to the power of 4. Oh, I happen to know that one, too, because 3 to the power of 4 is this cool one where you turn it into 9 squared, so that one's 81. So over here, this is, I'll show all my work just because I liked, and no, I'm not. Okay, it's 81. I've already shown my work once over here. I'm not going to do it again, but if you want to show it once, it's really cool to show that you know how to do 3 to the power of 4 really quickly in your heads by doing 3 squared and then squared again. Okay, so there's my answer. I could have gotten the same answer by finding the cube root of whatever gigantic number that thing is, but this is so much easier. Okay, we have the truly mega spicy problem of 64 to the power of negative 2/3. Negative is scary. What do? Yes, negative power, Mr. Sindel, you just flip it. Negative always means flip. So let me flip it right away and get rid of this negative because that's the scariest part of this problem. I can say that this is the same thing as 1 all over 64 to the power of now positive 2/3. Okay, negative is gone. Now I just need to worry about this fractional power. So again, I have 2 paths to go down. I can either take the power of 1/3 first, or I can take a power of 2 first. I like making it smaller first. So I'm going to make it a smaller version of 1 over 64 to the power of 1/3 first, and then to the power of 2. If I do 64 squared, I mean, it's not that hard. It's 64 times 64, which is a number that I don't know, but you could totally do it that way. I'm going to do it this easier way. I happen to know that the cube root of 64 is this a 4 to the power of 3, if you have remembered it from before. So this is going to be 1 over, oh, and pen though, 1 over 4. Again, 64 to the power of 1/3 turn into a 4. Now I still have to do this power of 2 to the power of 2. And 1 over 4 to the power of 2 is 1 over 16. And we have our answer. Just as a way to remember, if you have some sort of non-fraction to a power of a negative, your answer should be a fraction. If you didn't get a fraction, that probably meant you either did something wrong or you maybe started out with the fraction and it unfractioned itself by having a negative power. So that does conclude the notes for lesson 13-2 for Algebra 2. Thank you for watching.